Hello everyone. Well, the storm is coming, so I'm going to do a video update on that. I have an updated snowfall map, and I just wanted to start out by looking at the current satellite picture, because here I can show you that this is the piece of energy that's creating the storm out here across the upper plains, the upper Midwest. And out ahead of it, you have all this moisture, which is represented by the brighter whites of the clouds. So you have all this moisture out ahead of it, and then back up into Canada here, you have the trough that's going to be guiding this piece of energy up the coast as it moves to the south and east. So that's where we're at right now with the satellite. Now, the other thing that I wanted to show is I wanted to show the extent of these winter storm warnings and blizzard watches and blizzard warnings and all that stuff. All of these winter weather advisories and winter storm watches in the upper plains and Midwest is associated with that piece of energy that's hovering around out there. On the northern side of it, you have the cold air and the snow. And then up across the Northeast, you have all these winter storm warnings. And along the coast, if you can kind of make out that brighter green along the coast over Long Island, southern Connecticut, there's also a little bit of light green over here. Those are blizzard watches. And it is my belief that tomorrow morning these blizzard watches will go over to blizzard warnings. Okay, so now let's look at the 500 millibar as usual. So here's the American model. So at this point in time, pretty much all of the models, even the NAM now, the NAMs come around, I know, all of the models pretty much agree on the placement of the storm. There's not much variation anymore. And the reason for that is because this has now come on shore. And when this comes on shore, there's better sampling of initial conditions, so the models have a better idea of what is going on. And so that doesn't seem to be too much of an issue anymore. But there is still some sort of a difference between the GFS and the European model and the NAM. And it's not with the track of the storm, it's not even with the intensity of the energy that's creating the storm, it's with the extent of the precipitation. How far north and west does the heavy snow get? I think the GFS is underdoing it a little bit, and I will point that out as we go forward. So just to point out again, this is from earlier this morning. Let's go ahead so that I can get the trough into view here. Okay, so this is later tonight. Here is the energy that is creating our storm. And here is the trough back up across southern Canada that will be guiding this to the south and east and then up the coast. Alright, so just pay attention to this as we move forward. There it goes, moving to the south and east. And now you notice that it's starting to shift. It was originally like that, now it's going towards a neutral tilt. And same thing here right now, the main trough is positively tilted, but that is also going to be changing. And as I've pointed out several times in my videos over the last few days, the negative tilt is important because that steepens the flow and sends that up the coast rather than out to sea. It's really bad arrows, I'm sorry about that. Anyway, let's move forward. Also, notice how robust this piece of energy is. It's definitely stronger since yesterday in the model runs than it was in previous model runs. This piece of energy, all this this purple and red, it's definitely stronger than previously predicted, which is why a larger area of the Northeast is going to be impacted by this, because now it can fight the trough that's trying to suppress it and come up. Okay, so let's move forward. This is late Monday night, and this is still, we're going into early Tuesday morning. Now I want you to notice that your energy has gone negative and your trough has gone neutrally tilted, so now the flow is starting to direct it up the coast that way. Okay? And again, look at how robust it is. So with that, there it goes, shooting up the coast. Now your trough is negative. Now your energy's up into New England by Tuesday night. And then it shoots off up into southern Canada. Okay, so that is the dynamics part of it. The other thing I'd like to show, as you know, though, is the upward motion, because that gives us an idea of precipitation and whatnot. The more intense the upward motion, the more intense the precipitation. Okay, so we look at vertical velocity. All right, so let me go right ahead to okay. Let's go right ahead to, it's too far, late Tuesday night. Here we go. Okay, so by late Tuesday night, you have all this upward motion across the Delmarva. Look at all of this. Into northern Virginia, northern Delaware, central and northern Maryland, and southern Pennsylvania. So you are starting to thump with snow in this area. South of this, I'm a little concerned about rain and mixing. But that upward motion is pretty intense. Sorry, that I'm going to go over the European model a little later. Okay, so associated with that upward motion is all of this snow, which is picking up in intensity. And then the other thing that we have to keep in mind is that this is going to be a rapidly intensifying area of low pressure. So as this moves to the north and east, the pressure is going to be dropping rapidly, which means it's bombing out. And as that happens, on the northwestern side of a rapidly intensifying area of low pressure, on the northern and western side, that's where you get the most intense precipitation during the intensification process, not after it. It's during the intensification process that you get the heaviest precipitation on the northwestern side. We call it a comma head because it usually looks like a comma head of heavy precipitation. Okay, so moving forward with our upward motion. Oh, and as you could see that I pointed out before, your rain along the coast, if you're not in northern Virginia, you're further on south, and you're along the coast of southern New Jersey here and Delaware, you're all rain. But just to the north of that, you're all snow. It's going to be a steep gradient. Okay, so let's move forward. And that upward motion is still around. Again, actually still across the same areas, although some of it has now moved into southern New Jersey, and it has expanded a little bit into central Pennsylvania up here. So now you're going to start thumping away at around 3, 4 o'clock Tuesday morning. And we go ahead to early Tuesday morning. Take a look at this. Since the storm is intensifying, now you have intense upward motion just to the south and west of Philadelphia and to the east of Baltimore. So you are really thumping away in this area early Tuesday morning. And the upward motion is about to move to the north and east towards Long Island, New York City, and southern New England throughout the day. So now before I go forward with the upward motion, let's look at the precipitation here. See how it got the blue shading got darker. So as I said, Baltimore, Philly, even down into DC, just to the north of the rain and snow line, you are thumping away, and same thing in northern Virginia. And by the way, I have to give credit to Bernie Rayno for that phrase, thumping away. That's his phrase, and I've gotten so used to using it myself that I use it in all my videos. But AccuWeather meteorologist Bernie Rayno is always the one who says thumping away when he's talking about heavy snow. Anyway, okay, so now 7 o'clock Tuesday morning. Your heavier snow still around the same areas, but now starting to spread to the north and east. So now New York City and Long Island, you're starting to get in on this heavier snow. But your time is going to come midday. Really. See, because now the upward motion has spread to southern New England, Long Island, just to the east of New York City. So now you're going to be picking up heavier snow farther north and east in those areas Tuesday afternoon. See, look at the darker shading. Okay, now here is the difference between the GFS and the other models. The other models have this area of heavy snow all the way back up into here. Meanwhile, you can see that the GFS has it confined to the coast. Now, my thinking is that since you have a rapidly intensifying area of low pressure, that the heavy snow is going to be all the way back into Pennsylvania. And that's what the European model and the NAM show, and that's kind of conducive to how I came up with my snowfall map. I based it more on the NAM and the European model rather than the GFS. I agree with the GFS near the coast, but I think that heavier snow is going to be pushed back to the north and west further, especially since you have a negatively tilted trough as well. Okay, now I am running out of time, so I'm just going to go right to the snowfall map now. That just moves to the north and east up into Maine, and then by late Tuesday night, there's just lingering snow left over everywhere. Okay, so now I'm going to bring up snowfall map. Documents. No, I want to go to pictures. Okay. Here we go. So this is the snowfall map, folks. You know, I don't even have to be too specific with this. You know, it's a general 12 to 18 inches for most of the Northeast. Philly, you're in there, 12 to 18 inches. New York City and Long Island, 12 to 18 inches. Boston, 12 to 18 inches. Portland, Maine, 12 to 18 inches. Pretty much all of Maine except the extreme northern part of Maine, even up toward Caribou here, all 12 to 18 inches of snow. Cape Cod, you're going to be a little less because I think you're going to mix with rain a little bit, so we're going to go with 6 to 12 for you. State College, we're going to go 12 to 18 as well. Baltimore, I would say that the 12 line goes right through you, so I think around a foot, maybe a little more for you. DC, we're going to go 6 to 12. Okay? Now, you also have your main trough that'll be coming in from the west. And there's going to be additional snow associated with that. Oh, by the way, Albany, 12 to 18 inches as well. And then as you go towards further upstate New York, 6 to 12, because it'll be a little less, and then less than 6 as you get towards the northern tip of New York. But as I said, you have this main trough coming in, so there's going to be additional snow across central and eastern Pennsylvania as that comes on in. So that's concern number one. Concern number two is that as you get towards upstate New York and the Hudson Valley, up towards central and northern New England, the air mass is colder in these areas, so that means snow will accumulate quicker and it'll be easier. So two areas that I'm highlighting right now, central and eastern Pennsylvania, I would keep it northwest of Philly. And then as you go to I didn't mean to zoom in, but at this point we're going to go with it, towards central northern New England, I would try to keep it away from the coast, up into central and northern Maine, a good portion of Vermont to New Hampshire. You just got to watch out in this area for some isolated amounts of up to 2 feet. And same thing with the area that I highlighted before in central and eastern Pennsylvania. I think if anybody gets 2 feet, it's within these two areas away from the coast. But That doesn't mean I'm predicting 2 feet. That just means that I'm forecasting 12 to 18 inches, and if anyone does get 2 feet, most likely in these areas.